Today's lesson is substitution to find limits. So if a function has no holes or asymptotes at x equals a, then the limit as x approaches a is f of x is f of a. So basically what does that mean? If we're trying to find the limit as x approaches a, then the answer will be the function at a, as long as there's no holes or asymptotes. So the first thing we're going to do is substitute to see what the limit is. So if we want to find the limit, again, the limit of f of x, this is a function, is equal to f of a as x approaches a. So we're going to say a is 3, and we're going to plug that value in for the x's. So 3 squared minus 4 over 3 minus 2 equals 9 minus 4 over 1, or 5. So the limit as x approaches 3 of this function is 5. Okay, so finding a limit with substitution, you substitute the value in for x and you solve. So let's do number 2. Same equation, different value. So we're going to do the same thing. 2 squared minus 4 over 2 minus 2, and we get 4 minus 4 over 2 minus 2, 0 over 0, and we say, oh no, we can't do 0 over 0, that's undefined or doesn't work. So when you get to a case in which the substitution method doesn't work, you have to use method number 2, which is to simplify first. So we're going to go back to our original equation. We're going to factor. So if you don't remember, this is difference of squares. To factor difference of squares, we do 2 sets of parentheses. These are perfect squares. So we take the square root of x squared and put it at the beginning of both, and the square root of 4 and put it at the end, and 1 plus 1 minus, and then we put the denominator down below, and then we simplify. These are the same, so we can cancel them out, and we get x plus 2. Once simplified, then you're going to substitute. So instead of substituting into the original, which gave us no answer, we're going to substitute at this point. We're going to put the 2 in. So 2 plus 2 is 4. So the answer, the limit as x approaches 2 for x squared minus 4 over x minus 2 is 4. Okay. So now let's look at the next one. So we're going to plug in the 4. 4 squared minus 4 minus 12 over 4 minus 4. 16 minus 4 is 12. Minus 12 is 0 over 0. So once again, we need to use method 2. So we're going to simplify first. So we need to factor this. If you don't remember how to factor, remember the x method. We can use the x method. You multiply the first term times the last, negative 12. The middle term is negative 1. What multiplies to negative 12 and adds to negative 1? Negative 4, positive 3. So x minus 4, x plus 3 is the factor over x minus 4. These cancel and we get x plus 3. And then we substitute at this point. 4 plus 3 is 7. So the limit as x approaches 4 of this function is 7. So when we're talking about limits, and we've learned about limits by graphing already, I would suggest when you're doing your work, and you can do this and it's up to you, if you want to check your answers, to go onto this website. It's called Desmos.com. It's a free online graphing calculator. So you put in Desmos, DESMOS.com. You can see that in my browser. And then when you get here, you're going to hit Start Graphing. And if you go over here on the left, you can put y equals, so you're writing your function, y equals, and then I'm going to put in the function for this problem. So the x squared minus x minus 12 over x minus 4. So to do this, if I hit down here in the bottom, there's this little keyboard. If I hit that button, right, and I can actually click around to find some things, but if I hit that button and I want a fraction, so I'm going to put x, which is down here, and then squared, and then I'm going to use divided by to get the fraction bar, and then I can continue the top and continue the bottom. So we're dividing by, the bottom is x minus 4, the top is x squared, minus x minus 12. Okay, so I'm now just putting in the equation from the problem, and I should have my graph, so that I get a graph. Okay, that is the graph of this equation. The question asked, what is the limit as x approaches 4? So now we can use the method we were using yesterday. As x approaches 4 from the left and right, so I'm going to pull my graph down. From the left, as x approaches 4, it approaches the value 7. From the right, as x approaches 4, it approaches the value 7. So the limit as x approaches 4 of the function that we have here is 7. See how it's the same answer we got algebraically? So for this lesson, you should show the algebraic work, but you can also go check your answer by putting it into desmos.com and making sure the answer that you got matches the answer from the graph. So now let's look at example 4. So for example 4, we've got, if we plug in 3, we'd have 3 squared minus 9 over 3 minus 3, so 0 over 0. So again, we need method 2. Method 2, we're going to take the numerator, its difference of squares again. So the square root of x squared is x. The square root of 9 is 3. 1 plus, 1 minus. The denominator comes down. And we can cancel these. We get x plus 3. And now we're going to substitute 3 in. 3 plus 3 is 6. So the limit as x approaches 3 of this function is 6. So let's look at some more examples. So example number 5, you're going to notice this is no more polynomial. This has an absolute value instead. Doesn't change what you do. So first thing we do is we plug in the 4 for x in both spots, and we simplify. 3 times, this would be 3, is 9. 4 plus 4 is 8. So the limit as x approaches 4 of this function is 9/8. So again, if you get an answer when you substitute, you're done. If not, that's when you have to do method 2. So let's try this one. -1 squared plus 2 times -1 minus 8 over -1 squared plus 5 times -1 plus 4 gives me 1 minus 2 minus 8 is -9. This would be 1 minus 5 plus 4 would be 0. Okay, so we can't do this one. This is undefined. Okay, so the limit, then we would try method 2 to see if we can get an answer that way. So we take our numerator and factor it. We make our x. We get -8 and +2. So 4 and -2. So x minus 4, x or plus 4, x minus 2 is our factors. And then the denominator, we're going to make our x again. And we've got 4 and 5. So 4 and 1. X plus 4, x plus 1. The x plus 4's cancel. Let's substitute in -1. So we have -1 minus 2 over -1 plus 1. -3 over 0. The answer is still undefined. If it's still undefined after method 2, then you're DNE. It does not exist. Once again, you could also try graphing this with the Desmos. So if we put in the equation in Desmos, x squared plus 2x. And so if you get it does not work and you want to know whether it's going to work or not, you can also again graph it. So you'd get x squared. I'm just putting the equation in and I'll show it to you in a second. X squared plus 5x plus 4. And if I graph that, this is the equation I get. And if I zoom that, let me just move that. Sorry. Whoops, I hit the wrong button. Okay, so let me move this around. This is the equation I get. And the function asked as it approaches -1. As we approach -1, from the left, the graph goes up and along -1. From the right, it goes down and along -1. Notice how it never touches -1. So the limit does not exist. That's why we see that DNE does not exist. So as we approach -1, it does not exist because it's undefined at that point. So once you do your work, if you want to check, once again, make the graph on Desmos and see if it matches your solution. So let's look at number 7. This one gets a little more complicated. We plug in the 0. 1 over 0 plus 2 is 2, minus 1 over 2 over 0. We get 0 over 0. All right, so then we have to do our second method. Method 2, we're going to simplify. So we have 1 over x plus 2 minus 1 over 2. And that is all over x. In order to do this, we need to get a common denominator and simplify the numerator. So my common denominator is going to be 2 plus x plus 2, or 2 times x plus 2. There's a minus in between, 2 times x plus 2. So over here, I have a 1 on top. I have an x plus 2 on the bottoms. I need a 2. So the 2 is a new term. And over here, I have a 1 on top. I now have an x plus 2 on the bottom, so I put it on the top. Again, if I cancel the 2's, I get back where I started. If I cancel the x plus 2's, I get back where I started. So now I need to simplify this. So on the top, I have 2 minus, if I distribute this, x, and then minus 2, which would just give me negative x over 2 times x plus 2. And that whole thing is over x. And if I simplify that, I'm going to get negative 1 over 2 times x plus 2. And now is when I substitute in my value. So now I get to substitute in 0 for x. So negative 1 over 2 times 2 is negative 1/4. So the limit is negative 1/4. So that's if you have a fraction on the top, you have to get a common denominator and simplify. All right, and then number 8, last one. If we try method 1, 0 plus 4 squared minus 4 over 0, we get 12 over 0. All right, and if we get 12 over 0, we know that that's undefined. All right, if you do method 2 out, all right, all the way, because this is undefined, you're probably going to get a DNE if you want to check. So you notice how this has a number on the top. The ones that are 0 over 0 will solve further. The ones that have a number on the top are undefined. So when you solve them further, you're going to get something that's still undefined, and it's going to be DNE. So we can kind of jump to that conclusion, but if you want to work this out to check, if you take x plus 4 and square it, you'd get x squared plus 8x plus 16 minus 4 over x. So you get x squared plus 8x plus 12 over x. And that factors to x plus 6, x plus 2 over x. And now we substitute in 0. And we get 6 times 2 over 0, which would just be undefined. Again, DNE. So if the term is undefined, meaning there's a number on top and a 0 on the bottom, you're going to get DNE. The method 2 is not really necessary. You're going to get the same result. If you get 0 over 0, that's when you need to do method 2. And once again, you can check all of these on desmos.com if you want to check to see if your answer makes sense according to the graph.